Hello guys, welcome to my channel Java Junction. Today we'll discuss on building diamond shape pattern. This is a rectangular pattern and these are four boundary conditions. If we fill for all position of rows and column inside the boundary line with asterisk and leave empty for all position outside the boundary line, we will get a new pattern which we call the diamond shape pattern. So let's revisit the code of rectangular pattern which we had developed in our previous video and understand its working. Here we can see that for different value of I and j, these asterisks are printed on the position as seen. Every asterisk value is printed for unique combination of value of I and j. So every asterisk has unique combination of value of I and j, and this unique combination of I and j can be considered as coordinates of the particular asterisk. For example, this asterisk is printed for I equals 1 and j equals 1. So we can say that the coordinate of this asterisk is 1, 1, where first one corresponds to the I and second one corresponds to j. So writing the corresponding coordinate, that is value of I and j pair for all the asterisk, we get the following. Now we will draw the borderline on this coordinate grid system. We will make all the four borderlines required to create a diamond shape pattern and will observe the characteristics of this borderline, especially the value of I and j and their relationship along the line. Here we can make some meaningful observation in boundary line 1. This boundary line 1 passes through the point 1, 3, 3, 1 and 2, 2, where for each point the sum of I and j is always equals to 4. Similar observations can be made in boundary line 4. In this line, the sum of I and j coordinate for each point is always equals to 8. As 5 plus 3 equals 8, 4 plus 4 equals 8 and 3 plus 5 equals 8. Next, the boundary line 3 passes through the point 3, 1, 4, 2 and 5, 3. For all these points, we see that I minus j is equals to 2. The similar observation can be made for boundary line 2. Here, we can find that j minus I equals 2. So we conclude the four conditions of the boundary. First one is I plus j equals 4, I plus j equals 8, I minus j equals 2 and j minus I equals 2. So now we will modify the code of our rectangular grid. That is, we will print asterisk when certain conditions are satisfied. Otherwise, we will leave the space empty. So what we will write is, previously we had printed asterisk regardless of any condition of I and j. But now we will print asterisk based upon these four boundary conditions as we discussed earlier. So let's summarize these four boundary conditions and we will write, if I plus j equals 4 or I plus j equals 8 or I minus j equals 2 or j minus I equals 2. So if these conditions are satisfied, we will print asterisk, that is system.out.println print asterisk. Else we will print a simple space, system.out.print space. Let's run the code to see what's the result. But before running, we see that there is error in line number 13. In this line, we are making comparison of integer values And we need to remember that in Java, if we want to make comparison of integer values or if we want to make comparison of double values, we will write the equal to sign twice, that is equals equals. So let's correct all these 4 conditions and we'll check the output of the program. Here we got the void diamond pattern where asterisks are printed for the position only along the boundary lines. But we are trying to print the solid diamond pattern where asterisks are printed along the boundary line and inside the boundary lines. To cover the entire region instead of a single line, we need to understand the concept of inequalities. In this boundary line 1, I plus j equals 4. Right to the boundary line, I plus j is greater than 4 and left to the line, I plus j is less than 4. So the region I plus j is greater or equal to 4 covers the boundary line as well as the entire area right to the boundary line. Similarly, I plus j is less or equal to 8 covers the boundary line 4 and the entire area left to the boundary lines. Next, j minus I less than or equal to 2 covers the boundary line 2 and the entire area left to the boundary line, and I minus j less or equal to 2 covers the boundary line 3 and entire area right to the boundary line. So to print the solid diamond pattern, we need to print asterisk for the position of the row and column where these all 4 conditions are satisfied, which is inside the common region of these boundaries. Again, let's modify our code with this modified boundary condition. First is I plus j is greater or equal to 4. I plus j is less or equal to 8. I minus j is less or equal to 2. And j minus I is less or equal to 2. Since we are trying to print asterisk in the common region of these boundaries, we will replace the OR operator with AND operator. In Java, the AND operator is written as ampersand. With these 4 boundary conditions, let's check whether our required diamond pattern can be printed or not. Boom, we get the required result. Although we have got the required output, but here our all boundary conditions are calculated for 5 number of rows. Let's say we want to print a different diamond pattern with 7 or 9 or 11 number of rows. Then we need to recalculate all these boundary conditions and change these things in our program. Writing a program for a particular case is not desirable, so we want to generalize this program so that we can print the diamond pattern with any number of rows without changing the boundary condition at each time. Diamond pattern is a two-fold symmetric pattern. There is a central row above and below which the number of rows is equal, and there is a central column left and right to which the number of columns is equal. Let's assume there is n number of rows above the central row. So there will be same n number row below the central row and the total number of row will be 2n plus 1. As this pattern is twofold symmetric, the number of columns left and right to the central column will be n and the total number of column will be 2n plus 1. Let's generalize the earlier developed program in terms of n. This is a 2n plus 1 by 2n plus 1 rectangular grid where we are trying to create a diamond pattern. The number of rows above and below the central row is n and the number of column left and right to the central column is n. This line corresponds to j equals 1. This corresponds to j equals n plus 1 and this corresponds to j equals 2n plus 1. Similarly, this horizontal line corresponds to I equals 1, this I equals n plus 1 and this I equals 2n plus 1. Let's draw 4 boundary line as discussed earlier, and here we can see that for each line we can extract minimum 2 coordinate points the line passes through. Boundary line 1 passes through the point 1, n plus 1 and n plus 1, 1. Line 2 passes through 1, n plus 1 and n plus 1, 2n plus 1. Line 3 passes through n plus 1, 1 and 2n plus 1, n plus 1. And line 4 passes through n plus 1, 2n plus 1 and 2n plus 1, n plus 1. So we have 2 points for all the boundary line, and using the concept of coordinate geometry, if we know the 2 coordinate points along the line, we can find out the equation of line. Here the general equation of all these 4 boundary lines has been equated and tabulated as follows. We will apply this condition and make correction to our code. So coming to Eclipse IDE, we'll declare a new variable n, as we have generalized all our boundary conditions in terms of n, and for now we'll assign value 3 to n. Next, we'll change the definition of rows and columns. We write rows equals 2n plus 1 and columns equals 2n plus 1. Next, we'll change the boundary conditions and we'll write the generalized boundary conditions. So we'll write if I plus j is greater or equal to n plus 2, I plus j is lesser equal to 3n plus 2, I minus j is lesser equal to n, and j minus I is lesser equal to n. So with these 4 boundary conditions changed and the required modification in the code, we'll see whether you can get the required diamond pattern or not. Boom! We got our required result, and our result is as expected. For n equal to 3, we got 3 rows above and below the central row and 3 columns left and right to the central column. So now let's change value of n to 7, 8, 9 and again rerun the code to see whether our generalization worked or not. Now we can conclude that our program worked properly for any value of n, and that's the end of diamond pattern. I hope you liked my video. I would like to make a humble request to everyone to like, comment and subscribe to my channel, which is the only source of motivation for me. In the next video, we'll discuss more about boundary conditions and patterns. Till then, stay tuned. Have a nice day. Bye-bye.